Okay. All right. Good morning. Let's start. Today we'll study, some other type of malware like worms, rootkit, backdoors, and few others. Okay. In the last class we studied the virus, okay? And we see synonym or we looked at the analogy of computer virus with biological virus, right? Both have the similar kind of characteristics. Note that the types of malware can be as large as 100 plus, right? And malwares are also evolving, so it's not possible to cover all, not even at the definition level. Okay, so we'll just cover only few of these because we have just very limited time left out. And if you are interested, you can read it from any book. It's available in almost all book, right? I mean, this is very interesting topic. Okay, these are the references that I've used. So we'll cover some of these. Okay, and I will go very quickly because these are just we will touch only concepts. Okay, worms. When we say worm, what do you think about it? What comes to your mind? Anyone? How it could be different from virus? Ankita Chand, you are there today? Yesterday you didn't answer the
Yes,
question.
sir.
Okay, what do you understand from worm? How could it be different from virus?
So, baby, actually, sir, I'm not very clear about it.
Virus, what is the characteristic of virus? A biological virus or computer virus? Yesterday we discussed, right? 1 hour we spent on it. Okay, the biological virus or any virus requires a medium for transmission. Okay, it requires air, for example, or human body that can carry the virus, or other virus carried or animal bodies, right? And so it requires medium. Okay, so and it gets impregnated into a healthy code or healthy body or healthy cell to replicate. Okay. On the other hand, worms are something that scrolls, that does not require any medium or anybody's help, right? So it's designed to take advantage of whatever mechanism available to spread. And a worm in a machine can spread to all machines in the world, or almost all. Okay, if there are vulnerabilities in other machines, right? So it means that it has enough, when the code of the worm should have some mechanism to transmit itself to other machines. It means that it must make use of whatever communication mechanism available, which today is only internet. Okay, so it has code that can use internet. Okay, as simple as that, and then it can spread. All right, so definition is simple code that doesn't require user action to propagate, so it's intelligent enough to propagate. Okay, and it infects computers by altering the some already running code. And that's very important because for virus or any malware to be effective, it has to run. Otherwise, it will remain in the hard disk, right? So it has to become process, or it has become part of the process. That, and when we say process, it is a process that is going to be executed, scheduled. Okay, all right. So that's important, right? So unlike malware, unlike other malware, no user interaction is required, of course. This point we have already seen. These are mostly malicious. When we say mostly malicious, it means can worms be non-malicious? Yeah, there is a possibility. In the beginning, it was just people did it for fun. Okay, so but it may choke your system. Intent may not be malicious. Intent may not be to steal information or encrypt your hard disk or so on, but it can have some impact on machines. Okay, so there are some worms that are designed to be non-malicious, and all of us allow that. Do you know any worm or form of worm that, and based on that there is a, you know, multi-billion-dollar business happening? Possibly the world's largest IT company based on the simple concept. Anyone? Something that can come to the website, scroll through it, collect all the data, send all the data back into a database to put in a form that can be searched easily and give you result. Did you get the answer? Google, right? Or Bing or any other search engine. What do they do? I mean, how do they collect data? When you search for a keyword or something, okay, it cannot get all the information in going to all possible website in that few millisecond it has already gone. You create a website and there will be scroller that will come to website and scroll or collect information and then send it back to the some centralized or some server, and that will put into database, and this database will replicate in many places, and when you make a search, beauty is that the answer should come within some time. So point of telling is that the worms do exist and then may not be malicious. Okay, all right. So the characteristic is self-replicating, yes. Population growth, yes. Parasitic, no. It does not require any other medium, right? They are standalone. All right. When we say standalone, does not mean that it does here other. Okay, when we say other executable code, this may not be truly correct because it has to get into execution mode. How can it get into execution mode until it is scheduled or it has come to run list? Right? It has to run, so it may be part of some other process, or it has to change the scheduler. All right. Okay, so it means that it has to change the scheduling function. It means that it has to be part of then. It means that it has to change the scheduling function in the kernel space. It means that it has got to go into the kernel. It seems to be difficult. Okay. Of course, there are next topic that we'll study is rootkit, wherein it gets into OS. Okay. However, for our discussion, let's assume that it has to attach itself to something else. It's independent in the sense that it doesn't require other medium to transmit, but it has to execute. Okay, it spreads from one machine to another machine using network, which is internet today, and uses holes in networking software, right? Okay, it finds out bugs in networking software to spread itself. So it propagates fully working version of itself to other machines. It determines how to spread. Okay, it has to find out, it has got to have logic to find out where to spread, how, and those IP addresses, and so on. Okay, it usually causes resource exhaustion with repeated infection due to programming bug. So one way people, once there's a worm in a system, then what system admin guys do is that they remove the system, infected system from internet. Okay, they disconnect it. That's one way of, controlling the spread of virus, worm. How does it find new users to infect? It randomly generates 32-bit IP address. For IPv4, IPv6, it can also do same thing. Okay, so it must be using some random number generator which will generate 32-bit IP address. Okay, or it can be more intelligent, so it can do Google searches to find victims. Okay, or it can do scanning, the one which you studied earlier, right, in the last class. Okay, or it can look at the directory or IP addresses stored in the system and use those IP addresses. And there are many other ways. Or it could be passive, wherein it waits for user to contact you and reply. And then once it gets into other machine, then it finds out security flaws. Like it can attempt to guess password, system password, for example, or it can cause buffer overflow, or it can use trapdoor or backdoor, or which we'll study later. Okay, or it can have web vulnerability called kind of x-axis vulnerability. We will not get time to study this, but please Google it and find it out. So how does it propagate? I mean, it kinds of create a tree, right? And what shown here is a binary tree, which is, but it tree which propagation tree may not necessarily be binary tree. It can be, it can go to many other nodes and then machines and then spread further, right? So we can see that it's kind of in the beginning is exponentially spreads. Okay, and more computers are infected, the spread increases, right? Like this one. Okay, as number of levels go up, more nodes are covered, right? And after some time, that almost all vulnerable computer on internet get infected by this method, right? Okay. All right. So now the question is that can we draw parallels between spread of worms that uses internet and the COVID or any viruses that we have, in pandemic, and we'll see it is almost similar. Okay, so spread of worms depends on size of the population, proportion of population that's vulnerable to infection, like people like over 50 years of age, or and so on and so forth, who have some other diseases and so on, right? And the number of infected hosts, the more number of machines are infected, it spreads faster, right? And so on. But it follows exactly the same curve that we see in case of COVID, right? I mean, after some times, it initially is all exponential, and after some times flattens out because there is nobody, almost everyone is infected. Okay, all right. And these are some very famous worms, like Morris worms. Please read about it. And then this was created by a student, and then as an experiment, and spread all over the world, caused billions of dollars of losses. And then this guy was jailed, and he was son of very influential person, and now I think he's professor in MIT. Designing a worm is not easy, right? And he was one of the first few to design it. Okay, I think it's the same one. Then this another is called Code Red. Please read this also. NotPetya, this is another famous one. I would request you to please Google it and find it out. What are these and how do they work? Actually, for some of these viruses, you may also get some idea about the design. Okay, how does it work? See, challenge is that from any machine, it has to use its resources. Okay, so it means that it has to get executed. Okay, and then it has to use networking resources, right? All right, to send the payload or body of itself to somewhere else, and that machine has to accept it. So there, it's not simple design, right? It's quite complicated. Okay, so just think about it. Think yourself a designer of a friendly worm. Okay, that can go to all machines in a subnet, and think of not really a very large size subnet, but small size, maybe 20 machines. Then how do you design it? What all it should do? Where in OS, how it can exploit the vulnerabilities in OS, right? How do you spread it out to other machines? I mean, see, most of the machines work in client server method, right? So how do you send that payload such that other machine accepts it? Okay, just think about it. You may get some answer. Otherwise, Google it and try to find out what can be done. Okay, so look at from technical designs perspective, and it's very interesting problem to solve, right? What will be architecture of a typical worm? So think about it. Okay, all right. Any question? Can anyone work on a white paper on it? Advait, can you work on small white paper on it? How does it work actually? I mean, maybe just 2-3 pages. I mean, just what should be mechanism? And you can draw parallels with typical scholar for a search engine. I mean, maybe after exam, just think of writing something about it. It's interesting. Okay, this will require you to think about OS. Will require you to think about how to use networking resources. Think about how server is going to accept it, and so on. Okay, all right. Second one is rootkit. There is something called root, right? What is root? We often use this term root, right? In computer science, root is same as OS. Okay, so a malware that can go and exploit OS is rootkit. Okay, all right. So if you look at the most dangerous place for a computer is OS, right? If someone can, if an infection can go to OS, or malware can go to OS, then it has access to everything. It can do almost all mischief it wants, right? Okay, now the question is where in OS it can go and what all it can do. Okay, just think about it. Think about what all OS has. What does it control? It controls everything. Now, can this rootkit be in see, OS, as we study, has some routines in user space. Some are in the kernel space, right? Okay. Oh, these are privileged ones. This is trust area. Okay, and this boundary is very rigid, right? Through only system calls it one can enter, right? This we studied in the OS course. Okay, so where can this rootkit be? Best place, of course, the rootkit can be here, the user part, the user space of OS. Okay, or it can be here as well, right? If it's here, then it's very dangerous. All right. All right. So it can be in both places, right? Kernel part or user part. So now it's not easy to get into the root or the OS, right? But it requires a lot of strategy and tricks, and then criminal has to be technically very sound, and there has to be toolkit for it. Okay. So what intruder does is it takes advantage of one or more system vulnerability to deliver and install rootkit. So it has to deliver and install rootkit. Now note that this rootkit is not something that will go from one machine to another machine. You know, the criminals have to plan that they have to put a rootkit in a server, a specific server of an organization, or web server or some other server, right? So it's typically installed after attacker has obtained the root privileges. That's interesting. It means that it has cracked, or it has found out the way to log in, or it has the credentials or access rights into the kernel or OS. Okay, that is one by guessing password, or could be many other methods, some other methods. And once it has access to, once it has root privileges, then it can install their attacker tools. A number of tools it can install in the kernel, which can be, for example, log cleaner. There are tools to hide process files, etc. Network sniffer. Okay, like we have some network sniffer normal tools are available, right? They can, so but these network sniffers can be, which can look at the packets, IP addresses, and so on, payload, etc. It could be specially designed. Okay, or it can put backdoor programs. Backdoor means that it can create some APIs. Okay, and then using those APIs or some or login credentials, right? So it can create a say, for example, it can create some user ID and password so that cyber criminals can get into system anytime from outside. It's called backdoor or trapdoor. Okay, so these APIs is like in the this let's assume software, and then there's a normal door through which user ID and password one can use and access. It can create some APIs and say that if name is, for example, Ravi, let that process into the system, right? So these are backdoor. We'll study little later. Okay, so these attacker tools once are in OS are concealed. All right. So there are user level toolkits which will replace utilities like PS, LS, IP config, or IF config, replace key libraries. Now you see that in user space we have libraries, right? We have seen that there are various libraries are there, right? Which user program uses. Okay. Now, for example, we have seen that for buffering and so on, so forth, there are many schemes, right? So Now they use in fact syscalls. Now, how about replace this? Okay. All right. So there are many ways this rootkit can exploit this part. And then kernel level rootkit. So it can actually do a lot of things. For example, it can replace OS calls and utilities. Okay, and modified version of these routines. See, when there is a system call, right? When we say system call, what do you understand by that? It's finally is handled by a routine. Okay, and why not replace that routine? Once you are in OS, you can do that. Okay, or you can change pointer. If there is system call, a system call is nothing but is a pointer to a routine, right? You change the pointer to a malicious routine. Okay, all right. So rootkit can be in user space, so it can be a keylogger and backdoor, and then that will have access to something inside, right? And it can steal. Once there is a keylogger installed, then it will collect whatever is being typed out, like credit card information or Aadhaar card information, etc., and then can send it to some external entity, external master. All right. This is typical, this what a system is, right? Or OS is, right? So there are some libraries here which work in user space, and there is a kernel space stuff, right, which you studied in OS course, like system call table or interrupt table, process list, kernel code, etc., right? So it's part of kernel space, right? And there it can be also below kernel. Okay, so hypervisor, it could be at this hypervisor, for example. If like, I mean, you're running VM, then there is a hypervisor underneath which will emulate the functionality of OS on top, right? So OS will sit on top of VM. Okay, and then it can be below hypervisor, like device and firmware and so on and so forth, right? So this rootkit can be installed anywhere at below hypervisor level, at hypervisor level. Okay, then kernel space, and then user space of kernel. Okay, so one example is here. Okay, for example, when this is a normal flow, when a process is calling a system call, like open system call, so it will go to system call table, right? And then system call table will look at the pointer, which will point out to a routine which is inside OS, which will which will execute in kernel mode or protected mode. Okay, what could be one way of changing this, right? So this is a normal flow. Now what it can happen is that this open call will come here, but you change the pointer to I will open, right? So it's a malicious code. So system call is correct. Nobody will come to know. User will use the same system call, user level processes, and then it will come to system call table. Once interrupt is generated, will come to system call table. The system call table will have a pointer corresponding to open system call, because it has opens. It will surely it will have pointer. So instead of pointing it to the correct routine, it will point it to malicious routine, and then of course there will be finally control will be transferred to actual routine, so that nobody will come to know existence of this one. Okay, any question? All right. So, but this pointer is to be changed. What is another way of exploitation? Once you're in kernel space, right, and your toolkit, you can do anything. Now we say that in the virus or in case of worms, it has to inject itself into some other code such that that code gets scheduled. It gets scheduled, it means that it has come to run list or ready list, right? And then scheduler dispatcher will pick up one task or another which are in the ready list in first come first serve basis or some other mechanism, right? So once it's in the ready list or run list, then it will get executed. So why not change the run list? Okay, this is what it can do, right? So this is a normal run list. Okay, this is a particular sequence, so this will execute first, then process B and third process and so on and so forth. Okay, so by this pointer. Okay, can this be changed? So yes, it can be changed. So this is a hidden process can be brought in here because it's just a list, right? It's a linked list. Just insert an element and change these pointers. The job is done, right? So the malware can do this, right? Once it's in, there are toolkits available, tools available to make changes, it can do it. So this is another vulnerability. And there are just hundreds of such things Rootkit can do. It can, for example, change, it can delete a process in a certain process will never be. For example, there is a process that will check whether there is a malware. There is a malware checking process. It can simply give the least priority. It can change the priority of that so that it will never get scheduled. Okay, we have seen in scheduling algorithm, I mean, some processes starve. They are, because this scheduling is based on some criteria, whatever, first come first serve or shortest job first or whatever. And then it can change the scheduling algorithm so that this process, which is for virus detection, will never get scheduled. So it can do a lot of other things, right? Any question? Anything that comes to your mind? Are we going too fast? Advait?
No, sir, it is clear.
Pardon?
It is clear, sir.
Okay. What else you can think of in OS? If there is a rootkit, what all it can do? It can do, for example, it can encrypt the whole database of the organization. Okay, and then become ransomware. It can ask money. Okay, it can collect all the information and through backdoor it can send it to everywhere, to the master outside. Think of it. I mean, there are thousands of ways the rootkit can be exploited. You think about it. I mean, what we are discussing is just one or two examples, right? Simple things that can do. So OS presents a vast attack surface for rootkit. Right? We understand the attack surface, right? The places where attack can be done. And we always see that the attackers have always advantage, asymmetric advantage over defenders. So attack surface is very big in OS because, see, ultimately, what is the objective of OS? Objective of OS is what? We have seen that, right? I mean, without OS, we cannot use resources efficiently, securely. Okay, orderly. and many others. So if OS is impacted, then all these parameters will be impacted. Reliability, for example. Okay, so OS is something is the most important part, needs to be protected, and rootkit never should be allowed to be there. So how do you detect rootkit? See, rootkit operates by maliciously modifying kernel data structures. So modifying function pointers we have seen, right? Modifying process list, modifying even pseudo number generator. Okay, so how do you find out there's a rootkit? Of course, you can look at the behavior of computer and then possibly find it out. But then today the problem or good thing is that the processes are so fast. Okay, and there's so much of RAM and other resources that even if there is a rootkit is using resources, one can never find out until rootkit's purpose is to exhaust the resources. So question of resource exhaustion does not exist if rootkit doesn't want it to do. Then how do you find it out? That because when I had first machine I bought, PC80, if there was a virus, then everything will stop working. I can see that system is slow down. There's it will take huge amount of time you want to read a file and so on, right? I could find out there is a virus. But today, if my laptop is a virus, I cannot even find it out until the virus itself does something such that its effect is seen. If the intent of the virus is to show itself, only then I will come to know. Okay, otherwise I will never come to know, because I have kind of huge amount of resources in my laptop. So it's a 8 core and few GBs of RAM and so on and so forth. When I had 64 KB of RAM, then a virus will take some space, right, in main memory, and I will immediately come to know. Okay, so only way is that continuously monitor the integrity of kernel data structures, because it works by changing kernel data structure. Okay, so I can have an integrity monitor, but can this rootkit change this? Is it possible, right? If it is a part of OS, then it can change it. It can disable it. So it means that, of course, I mean, we always assume that OS is trusted region. It is 100% protected. But if this become untrusted, then there is a need for some separate higher level of trust in a system that will run this integrity monitor. So we can use external hardware such as coprocessor, hypervisor, and so on and so forth. We can have kind of separate system that will check these data structures of a machine. How can you design this? Think about it. Okay. All right. So basically now, if we have system like this separate system like here, then it can continuously check the integrity of this. How can it check integrity? It means that it should have previous version of it stored and then monitors. It will look at the modified version and compare and find out there is some change. Okay. For example, function pointer values in system call. See, function pointer values, this value which was initially showing here will never change, right? It's kind of static. Okay, if this changes to this one, this monitor, activity monitor, will find this out. All right. Okay. Okay. So rootkit is we will use behavioral based method to find it out. Signature scanning and so on so forth. All right. So this is what. So we have today covered two things: worms and rootkit. And also we have discussed in brief backdoor or trapdoor. And we mentioned it some time back, right? When so every organization has a backdoor. You know, go to a company, when you go to a company, you will see that apart from main door, you know, main entrance, everything is done in the main entrance, right? There is a security guard often, and there is a, you know, fingerprint based method for access control. Okay, but there are other parts of the system or building when somebody can get out. Okay, and the experiment was done in US, and then there is agency that specializes in all this. You know, was given task to find out what are the security holes, and person what simply did is that pretended to be employee of the company, used created a you know, fake ID card. Okay, now this fake ID card or fingerprint, if he uses through main door, they will get caught. He will went to the back door of the building, back side of the building, and there is kind of smokers lobby. Smokers always come out from some of these doors. Okay, because smokers don't want to come out of the main access, right? Because it takes a lot of time. So they, and then he pretended like employee asked them one of the questions about department and so on and work and so on, and then tailgated them. Tailgated means that without using access control, just followed them up, right? Okay, this is a backdoor. All right. And every system usually has a backdoor, like your mobile phone, Android phone has a backdoor. What does it mean? Do you think that you are only monitoring your data? Government cannot monitor it? Can government monitor what you are doing? Yes, because there is always in your system, there is a some access control given to them through a backdoor, or it's called trapdoor. So 100 million Android use now, I don't know, it will be much higher. It's an old diagram, right? Has may have backdoor on their device, and nobody announces it. You will not buy Android phone if you are told that it has a backdoor. It means that somebody else can see what exactly is happening in your mobile. They can reach each and every data that's coming in there, right? Okay. Okay, so basically you log in, when you go to a website, you try to log in. When you try to log in into that, then use your credential which you have created, if you are allowed to do that. Okay, but there is a possibility that their backdoor, wherein employee has created a backdoor or their system admin guys have created a backdoor, such that they use that backdoor. If you simply, you know, some user ID as common or whatever, it will allow to get into it, right? It may not be normal login process, but maybe they need to call something else to get into it. Okay, so these can be planned backdoors, like most mobile phones have this backdoor. Okay, uh, or accidentally placed backdoors, because you know, for debugging etc, you know, designer or developers have placed a backdoor because they think that, you know, they will go home and do the testing and so on and so forth. Okay, so those backdoors can be there, which are there only for short time, but it will remain in the system because somebody would have forgotten. Or backdoors planted by criminals. like a rootkit, once it has got access to everything, will create an API in the code through which any external entity can access it, right? Or the master can access it. Okay, all right. Now, all these things come to high visibility when FBI agency in US, right? It wanted a backdoor on iPhone. And then Tim Cook, the present CEO, said no. You don't know actually, he said no or yes. Possibly no, but what happened to Android? Is there something that is they allowed? Maybe. Is there? Nobody knows. Okay. So of course we can see the self-replicating no population goes 0. Secret entry point program or system is a special way to gain access to system without usual user authentication. So without having a user ID and password, which is legal and authentic through authentication, one can get into system. Okay. It typically works by recognizing some special sequence of inputs or special user ID. All right. So now all this we have looked at. Example is that this is a normal code. This part is normal code. Okay. If user ID is that read user ID and then read password, it matches, then fine. Now this line, if is inserted, if username is 133 whatever, hacker or whatever, allow login. Now this part creates a backdoor because it's not through normal authentication method. All right. Okay. So of course you can read this, it's very simple. So is it safe to create backdoors in commercial programs? Of course no. Who all know about the backdoor? An ex-employee or employee who's disgruntled employee, really angry about the company, might have created a backdoor and left the company thinking that we'll exploit it later. So there's a possibility, yes, it can be created by employees. It can be result of programming error, yes. How can one detect backdoors? How can one detect backdoors? Anyone can tell me? How can you detect backdoor?
Trying different keys while switching on the phone.
Pardon?
Like sometimes when we switch on the phone, restart the phone,
Mm-hmm.
we use the power button and top volume up button for just booting. So there might be some other keys and some other set of set of inputs to follow. So
Okay.
maybe it might lead to login of a backdoor or something.
Yeah. So basically you'll have to do exhaustive testing in some sense, right? But the codes, what is the code size of OS? Android? How many lines of code? Approximately 30-40 million lines of code. I don't remember it when I was part of Symbian Nokia. It was 5-6 million. Okay, now it's gone up to 30-40 million lines of code. How do you do exhaustive testing? These are not, in fact, testing is the biggest expense most companies face, because testing cannot be done. 40 million lines of code cannot be tested, and releases are often, right? Very often, right? So you cannot do full testing. You'll have to do only incremental testings. Okay, even if you have automated test use. Okay, the one possible way to find out backdoor is by looking at the code or code inspection. Actually, a programmer, expert programmer will sit, look at the all code, and look at the where access control is happening and see somebody has actually made some changes. So you can have some tools to check, actual source code and modified source code and so on and so forth. Or you create very strong check-in processes, right? When somebody is trying to insert malware, a disgruntled employee is trying to insert, a backdoor, then somebody will find it out. Okay, but usually in organization, check-in process is not so strong, especially in small organizations. So backdoor is a possibility. Okay, another few minutes. Logic worm. A disgruntled employee can change the code or create a small logic encode and say that at certain point in time it will burst. It means the whole code will become dirty, or it will encrypt the code, or system will start doing malfunctioning, right? Okay, so this kind of Boolean condition is evaluated, it controls when payload is to be executed. So for example, if the date is Friday the 13th, crash the computer. Again, it's an insider job, because insider will change the code and leave it like that, leave the company, and at certain date it will crash the system. Okay, there are a lot of examples, right? You read this out. All right, to summarize, malware is attacker code running on victim's computer. It can be launched, it can be used to launch various effects. It can be of virus or worms or 100 other types of malware. What we have studied today in the last two classes, aspects of virus and worms. Okay, detection is usually signature based detection. There are antivirus, flags of unfamiliar code, etc., etc. Propagation method we have studied in last class was okay. About the virus, which changes its form, is like polymorphic code, metamorphic code, and because of these two changes its appearance, then it's very difficult to find out through signature based detection. Okay, and then today we studied about Rootkit, a malware in OS that hides its presence. All right, please go through these slides, Trojan horse, and then we have ransomware, then exploit kit. Just go through it. I may not ask any question on these topics, but just go through it. All right, in the next 2 lectures, we have 3 more lectures left out. So 2 lectures we will cover something that is a fun topic, that is cryptocurrency and blockchain. Okay, and the last lecture we will have a complete overview of the course. All right, okay, thank you.